Hi all, this is Steve Scully. I'm reading from my book, The Instruction Manual, as it is written in the Cosmos, and I'm going to pick up where the last video left off in Chapter 1, Section D, When Newton's Laws Were Held in Esteem. Throughout the history of science, there are several instances where an entire concept has been completely dismissed in favor of a new way of interpreting observations. This is alike to throwing something of value in the trash, where it then becomes buried and hidden from view. In today's world, classical mechanics is a stepping stone, a simplified version that is not perceived as a fundamental description of the reality we live in. If something disagrees with Newton's laws, it is not thought to be because of a lack of full understanding, but rather it is concluded to be because Newton's laws were wrong. As a result, quantum mechanics, general relativity, and the Big Bang models have become, quote, standard models to describe the universe. In this, classical mechanics has fallen largely into the pages of the history books. Nowhere to be seen are the scientists who are studying. Sorry. Nowhere to be seen are the scientists who are searching for the connections between new observations of the cosmos and Newton's laws. The Big Bang model is a perfect example of this. Prior to the discovery that the light spectrums from all galaxies in all directions beyond a certain distance were redshifted when the galaxies were beyond a certain distance away from Earth, the concept of the steady state universe was the prevailing perspective of the cosmos. This is a model where the universe was thought of as eternal and generally unchanging. Redshift occurs with the absorption line pattern. Redshift occurs when the absorption line patterns caused by the specific particles absorbing light from the source galaxy are shifted towards lower energy positions so that the same pattern exists but shifted, as shown here in figure 2. So we just see absorption line patterns, and the same pattern exists shifted towards the red spectrum, and so we call this a redshift. Due to one group of related observations alone, centuries of compounding thought and research were entirely dismissed in favor of the Big Bang model, in favor of a model whose foundation was built upon the interpretation of the single group of correlated observations. The model hinges entirely on the interpretation that this redshift in the light spectrum is caused by motion, where redshift in particular is caused by motion away. It further elaborates on this motion so as to not break the laws of physics by adding so-called expansion of space and dark energy. These new additions to the fundamentals are sufficient to demonstrate the model does not follow logic and reason, as Occam's razor, which states the simpler answer is more likely to be true, argues the addition of more complexity into the claimed fundamentals of how the universe functions is illogical. Moreover, when we make the observations, there is no way to determine the actual cause of redshift. We just see redshift. We do not see motion. The Big Bang model does not mention this, that this redshift could be caused by another known means, gravity. However, rather than seeking an answer in gravity, science jumped to the conclusion that motion of some form was the cause, and as a result, that the Big Bang happened. In one fell swoop, physics was warped into a skewed reality. Importantly, this all occurred because those analyzing the observations at the time they were made could not deduce a specific means by which gravity could cause what was seen. What could be deduced, though, was an apparent explanation using motion instead as the cause. and so logic and reason of natural philosophy were abandoned offhandedly as the first explanation to arrive was taken as factual even in spite of its shortcomings. It was not always this way. Richard Feynman discussed in The Character of Physical Law, anomalies that did not match the predictions made by Newton's laws were critically analyzed for what we could be missing that would make Newton's laws recognizably produce the observations. In the case of the moons of Jupiter, it appeared that the predictions were distinctly not in line with the observations. Rather than developing an entirely new way of looking at the universe, those considering this anomaly held Newton's laws in esteem and set about trying to recognize what critical missing link was unknown that was not enabling predictions to match the observations. As Richard Feynman states, Mr. Romer, having confidence in the law of gravitation, came to an interesting conclusion that it takes light some time to travel from the moons of Jupiter to the Earth, and that what we're looking at when we see the moons are not how they are now, but how they were the time ago that it took the light to get here. And by the fact that they were this much too early or that much too late, was able to determine the velocity of light. This was the first demonstration that light was not an instantaneously propagating material. I bring this particular matter to your attention because it illustrates something, that when a law is right, it can be used to find another one, and that by having confidence in this law, if something is the matter, it suggests perhaps some other phenomenon. And if we had not known the law of gravitation, we would have taken much longer to find the speed of light, because we would not have known what to expect of Jupiter's satellites. This process has developed into an avalanche of discoveries. Each new discovery permits the tools for much more discovery, and this is the beginning of that avalanche which has gone on for 400 years in a continuous process, and we're still avalanching along at high speed at this time. End quote. Nowadays, this confidence in Newton's laws is non-existent in the search for further understanding of the universe. This is evidenced by the lack of any theoretical or experimental research at the academic level into how Newton's laws apply to newly made observations. General relativity, quantum mechanics, and the Big Bang are the only fields of research considered of any value. This does not mean that any are actual descriptions of reality, however. Rather than holding confidence in Newton's laws, which are based firmly in natural philosophy, we have stepped away from philosophy and began a rigorous process of attempting to explain observations through complex mathematical equations that have nothing to do with classical mechanics. This method does not appreciate the value of Newton's laws, which are philosophical in nature, as was prominent in the past. In much the same way as how the speed of light was recognized to not be instantaneous by holding confidence in the law of gravity, this book will show that the same can be said of the other fundamental forces, quote, causeless forces behind everything we see, as well as the rest of nature, by holding confidence in the laws of classical mechanics. Not because of what they are, but because they are based in thoughtful consideration and function as a doorway to understanding. When logic and careful thought is replaced by jumping to conclusions and disregard for the universality of fundamentals, anything can be claimed to explain the universe, but only when logic is held as a hinge and thereby classical mechanics as a beacon, can we follow through to deduce the fundamentals of reality as they truly are. So I'm going to just go ahead and stop there and continue on in the next video on the sharpened point of scientific progress. Thanks for stopping by.